If you want to compute sample variability by hand, and I don't recommend it, but if you're going to do it, you need a few things first. The very first thing you need is a new formula. And then you need a spreadsheet, like Excel, to help with the math. And yes, I know that Excel can calculate standard deviation directly, but you said that you wanted to learn to compute sample variability by hand, so please stop interrupting. As I said, the first thing that you need is a new formula. I've given you this definitional formula that we used to understand the relationship between the sum of squares, variance, and standard deviation. It is a perfectly serviceable formula, but using it is cumbersome, and it requires a great deal of calculation, so no one actually uses it when calculating variability by hand. However, there is an easier way. Using some algebra, we can transform this definitional formula into one that is much easier to use. A definitional formula is one that strictly follows the literal definition of a statistic. It clarifies concepts, and it's easier to teach. And while the definitional formulas are usable, the computational formulas simplify calculations when working by hand. Although it may look more complicated, it is really much easier to use. To use this formula, you will only need two columns in Excel, the sum of x and the sum of x squared. So here's our strategy. We are going to create a data set in Excel. We will put all of our data into the first column, called the x column. We will then create an x squared column using a formula, copying it to the lower cells as necessary, and finally, we will add up the columns using summation to create the sum of x and the sum of x squared. These values will be plugged into our new formula. So, we need some data. For reasons that I don't want to go into, I was at the food court at the mall, minding my own business, eating a gyro, and listening in to a conversation between three teenage girls on the other side of a large potted plant. I did not mean to be listening in. I was not particularly interested in listening in. But the volume at which they were conducting their exchange meant that I was like one of those N-1 degrees of freedom. I didn't have a choice. At one point, one girl asked the other, "So, do you love him?" And the other one replied, I like him. I mean, not but you know. Interesting sentence, that. I calculated it to be 50% like. I consider it a remarkable linguistic feat that I am unlikely to hear bested in my lifetime. And I go to the mall a lot less now. But this led to some interesting research. So you decide to count the number of times that both adults and teenagers use the word like when describing a video they have just watched. I will give you the dummy data, and then we'll use Excel to calculate the standard deviation of each group by hand. Here are the data. Let's go to Excel to enter them. We will begin by opening a new Excel workbook. Let's label column A, adults, and column B, teens. And we'll make them bold. Then we will enter the data from the earlier sheet. For the sake of time, I will speed up the data entry. Now let's enter the data for the teens. All right, good. Now let's do something else. I want to copy these data to sheet 2. I'll select all of the data, right-click, control-click, or use Edit, Copy. Then move to sheet 2. I'm going to control-click and paste. Then I'm going to do a cut and paste, selecting the row for teens. I'll use the keyboard command, Command X, select row C, column C, and paste. Now the reason that I'm doing this is so I can create an x squared column following each of these two columns. So put your cursor in cell B2 and type the following formula. =A2 * asterisk A2, enter. That is the x squared. We can copy this formula down by clicking on B2 and then double-clicking on that small box to fill in the rest of the data points. Let's do the same thing for teens. Only this time we'll use the formula equal sign, click on C2, and then shift 6, caret 2 is squared. Double-click, and we've now filled in the x squared values. Now let's sum them up. We'll scroll down slightly. For that, we'll need the formula equal sign, sum, and the values from A16 up to A2, close parentheses. There is the sum of the x values. I can copy that across by dragging, and I'll make those bold to help set them off. Now, just so you know, you can calculate means and standard deviations directly in Excel. For instance, I could use the formula equal sign, average, A2 colon A16, and get the mean for the adults. I could use the formula equal sign STDEV, A2 colon A16, to get the standard deviation, 2.12. You can check these against the values from SPSS later to make sure that they match. Also, do not use the formula equal sign STDEV dot P, A2 colon A16, because that uses n in the denominator, and that standard deviation will be incorrect. So now we are ready to plug in the values for each x and x squared column into the standard deviation computational formula to calculate the standard deviations for adults and teens. To calculate the standard deviation for adults, we see the data on the right and the formula in the green box. I've also included the summary data in a blue box. We begin by plugging in the summary data into the standard deviation formula. 1484 plugs in for the sum of x squared. 146 plugs in for the sum of x. And n is 15 in both places that it appears in the formula. So now let's start doing some math. 146 squared is 21,316. That needs to be divided by 15, and we can also clean up the denominator. In the numerator, we have 1484 minus 1421.06, and the denominator is now 14. So do some subtraction. 62.93 divided by 14 is 4.4952, and as our last step, we take the square root and get 2.12. The estimated standard deviation for the population is 2.12. Now you try. Estimate the population standard deviation for teens. Remember to use n minus 1 in the denominator. Try it on your own to make sure that you know how to do it. If you've calculated the answer correctly, it will be 2.97.